Welcome to This Explainer. Today, we're diving straight into one of the most terrifying, mind-bending phenomena in our entire universe. We're talking about the cosmic abyss. So fasten your seatbelts because we're leaving the safety of Earth and jumping right into the darkness.
So here's a massive question for you. What actually happens to the universe's absolute fastest entity, light, when it encounters the ultimate gravitational trap? I mean, we know light just absolutely zips through space, right? 186,000 miles per second. But there's a place out there where the gravity is so immensely powerful that it literally swallows that light whole. How is that even possible?
Well, that brings us to the black hole, a highly compressed region in space where gravity is so extreme that the laws of physics just fail, and nothing can escape. It's not just some empty pothole in space. It's an area where matter is packed so incredibly densely that it warps the very fabric of space-time into this insanely steep, inescapable well. The gravitational pull curves space-time so deeply that light's path bends entirely inward. Even racing at its absolute maximum speed, light just can't climb out.
And the very edge of this trap, that's the event horizon. It acts as a blind, bottomless well and a strict point of no return. You can think of it as the absolute edge of the abyss. The exact microsecond light crosses this invisible threshold, its path points entirely toward the center. It's swallowed forever, just plunged right into pure, inescapable darkness.
But, if a black hole swallows all the light, how do we even know it's there? The answer is the accretion disk. It's this violently glowing ring of dust and superheated gas from shredded stars swirling around the dark center. Basically, the black hole's gravity is ripping neighboring stars apart, and all that cosmic debris heats up from the sheer friction. It glows blindingly bright, which essentially gives us a perfect silhouette of the invisible beast hiding inside. So we're faced with this wild paradox, the invisible inner void versus the glowing outer ring. We're looking at one of the most fascinating contrasts in physics here. The core itself is terrifyingly dark because it's actively devouring all incoming light. But then it's framed by some of the most brilliant, violent light in the entire universe, the glowing remains of stars just caught in its fierce orbit.
So just how big are these traps? Well, let's start incredibly small, like one single atom. Scientists believe miniature black holes formed right after the Big Bang, and they might literally be microscopic. But hey, don't let their tiny size fool you. They are so ridiculously dense that an atom-sized black hole packs the mass of a massive mountain. It could easily consume anything in its microscopic path.
Stepping up the scale, we've got stellar black holes. These are formed from a blinding supernova star explosion and measure roughly 10 to 25 times the mass of our sun. When a giant star runs out of fuel, it detonates. It releases energy that can literally outshine entire galaxies for weeks. Then, the core collapses inward on itself, leaving behind this massive dark void.
Now, I want you to picture the number 4 million. That is the unfathomable scale of Sagittarius A star, the supermassive monster resting right at the center of our very own Milky Way galaxy. It packs an incomprehensible 4 million times the mass of our sun. Just wow. These supermassive beasts likely formed right alongside the galaxies themselves, and they sit at the center of almost every major galaxy out there.
Which naturally brings us to a deeply terrifying, kind of personal question. If you were to actually fall past the event horizon, what exactly would happen to your body and to time itself? Let's take a hypothetical physical journey down into the ultimate light trap.
Scientifically, the answer is spaghettification. It's extreme gravitational pulling that violently stretches a falling object into a long, thin noodle shape. It's got a slightly silly name, but it is a very brutal reality. Because gravity is pulling incredibly harder on your feet than on your head as you fall in, your body would just violently stretch. You'd be pulled into this long, thin noodle before being completely torn apart at the atomic level. Yikes.
But it gets weirder. Because it's not just your body that distorts, it's time itself, thanks to an eerie effect called time dilation. Think about your view falling in versus an observer's view. From your perspective, looking back out, you'd see the outside world drastically speeding up, like a movie in fast forward. But an observer, say a friend safely on Earth, actually scratch that, anyone watching from a safe distance. They'd see you slow down as you approach the edge. You would eventually seem to freeze perfectly in agonizing slow motion, just slowly fading away as the light escaping your image is stretched to its absolute limit.
All this cosmic destruction usually leads to one big fear we all kind of have when looking up at the sky. Could our own sun collapse into a black hole and swallow the solar system's light? It's definitely a frightening thought to imagine the center of our solar system just suddenly going completely pitch dark.
Well, you can breathe a huge sigh of relief. The short answer is no. Our sun is simply too small to form a black hole. It will eventually expand, turn red, and cool down into a harmless white dwarf star. It just doesn't have the intense mass required to collapse space-time and trap light. And even if, by some magical sci-fi scenario, it did turn into a black hole with its exact same mass today, our planets wouldn't instantly get sucked in. They would just keep orbiting in absolute pitch blackness, freezing without the light.
Okay, so our solar system is safe from the inside, but what about the outside? Could a rogue supermassive black hole wander by and consume our entire Milky Way galaxy whole? Like if they're the ultimate cosmic vacuums, could they just suck up everything around them?
The crucial point here is a matter of pure scale. Black holes are incredibly powerful, yes, but an entire galaxy is vastly too large and spread out to be consumed entirely. While a black hole would effortlessly shatter Earth into pieces if we accidentally fell in, a galaxy spans hundreds of thousands of light years. To a sprawling galaxy, even a supermassive black hole is practically just a speck.
So, let's look at one final survival scenario. Is there any technological or physical way to escape a black hole once you cross inside? Say we build some ridiculously powerful spacecraft way out in the distant future. Could we simply thrust our way out?
The answer cements the black hole's reputation as the ultimate cosmic trap. Escape requires traveling thousands of times faster than the speed of light, a feat that is physically impossible. Because the gravity well is so impossibly deep that it bends the path of light entirely inward, once you cross that event horizon, it is literally the end of the line. Absolutely no way out.
Now, you might be wondering about an amazing paradox here. If black holes trap all light and are totally invisible, how do scientists actually find and observe them? If they're practically invisible holes in the universe, how do we confidently know they're actually out there across thousands of light years of space?
Well, it took decades to solve this. Back in 1916, Karl Schwarzschild theorized black hole compression using Einstein's math. Back then, people thought it was just a mathematical fairy tale. But fast forward to 1971, and the very first black hole was officially observed a massive 6,000 light-years away from Earth. That definitively proved the 1916 math was right all along.
And today, we have incredibly powerful tools to hunt for them. Just think about a distance of 1 million miles. That's exactly how far NASA's incredible James Webb Space Telescope sits from Earth. By capturing distant, faint cosmic light, these powerful space-based instruments can peer deep into the galaxy. They observe those glowing accretion disks and the immense gravitational pull these invisible giants have on surrounding stars, officially bringing the invisible right out of hiding.
Which brings us to a final, deeply provocative question. If a black hole is the ultimate cosmic trap that devours everything, could a mathematically predicted white hole be out there doing the exact opposite? Like a cosmic geyser, violently expelling light and matter. Are these hidden somewhere in the deep corners of space, just waiting to completely rewrite our understanding of reality? The universe is incredibly vast, and its greatest mysteries are really just waiting for us to shine a light on them.